Right now, you're probably complaining about the weather. Too hot, too cold, too humid, whatever. You've got opinions about it. You check an app, you adjust a thermostat, and somewhere in the back of your head, you assume that no matter how bad it gets outside, you'll be fine. Now imagine a place where bad weather means the ground beneath your feet is hot enough to melt lead, where the sun is 3 times bigger in the sky than it looks from Earth, where there's no wind, no rain, no clouds, no air, and no atmosphere standing between you and the full, unfiltered fury of a star. That place is Mercury, the closest planet to the sun, and it is one of the most hostile environments in the entire solar system. Not because it's dramatic or exotic, but because almost everything that keeps you alive right now is completely absent there. Every single layer of protection you take for granted, gone. So let's talk about what would actually happen if you tried to survive on Mercury. Not with a spaceship or a future colony dome, just you, on the surface, trying to last as long as possible. How long would you make it? What would kill you first? And what would it even feel like? Let's start with the temperature. Because Mercury is the planet closest to the Sun, most people assume it's the hottest planet. It's not. That's Venus. But Mercury is still absolutely brutal in a way that's almost hard to process. On the side facing the Sun, surface temperatures reach up to 430 degrees Celsius. That's 800 degrees Fahrenheit. Hot enough to melt zinc, hot enough to melt tin, hot enough to turn lead into a puddle on the ground. The rocks themselves glow with stored heat. But here's where Mercury gets genuinely strange. Flip to the other side, the side facing away from the sun, and the temperature drops to negative 180 degrees Celsius. That's minus 290 Fahrenheit. In the same place, on the same planet. The difference between the two sides is over 600 degrees. No other planet in the solar system swings that hard. The reason is Mercury has almost no atmosphere. On Earth, the atmosphere acts like a blanket. It traps heat, moves it around, keeps things relatively stable. Mercury has basically nothing. A few stray atoms of hydrogen, helium, and oxygen clinging to the surface. Scientists technically call it an exosphere rather than an atmosphere because it's so thin it barely qualifies. Without that blanket, heat doesn't spread. The sun-facing side cooks. The dark side freezes. No in between. And here's the part that really breaks your brain. Mercury rotates incredibly slowly. One Mercury day, one full rotation, takes about 59 Earth days. So the sun-baked side sits under direct sunlight for weeks at a time before it rotates away. You're not talking about an afternoon in the heat. You're talking about nearly 2 months of continuous roasting with nothing to stop it. Now let's talk about what this means for you specifically. You step out onto the surface on the day side. The ground temperature is 430 degrees. The rocks around you are radiating heat in every direction. Your boots would fail within minutes. The suit material would begin degrading almost immediately. And even the most advanced spacesuit we've ever built was not designed for sustained exposure to temperatures that high. NASA's suits for the moon top out at handling around 120 degrees Celsius on the surface side. Mercury is more than 3 times hotter than that. You'd be cooked from the outside in, like standing inside an oven that has no off switch and is also made of rocks that are themselves on fire. But let's say you somehow survived the heat. The radiation would finish the job. Mercury has no global magnetic field strong enough to deflect solar wind the way Earth's magnetosphere does. Earth's magnetic field is constantly intercepting streams of charged particles blasting out from the sun and deflecting them around us. Mercury's field is about 100 times weaker. That means solar wind hits the surface almost directly. Cosmic rays, X rays, ultraviolet radiation, all of it arrives at full strength with almost nothing in the way. On Earth, you get a sunburn after a few hours on the beach. On Mercury, unprotected exposure to that level of radiation would start damaging your DNA within minutes. You wouldn't feel it happening. That's the terrifying part. Radiation poisoning is silent. By the time your body started showing symptoms, nausea, hair loss, organ failure, the damage would already be done at a cellular level. And if the heat and radiation weren't enough, there's the meteor problem. On Earth, space rocks burn up in the atmosphere before they reach the ground. You've seen a shooting star. That's a rock the size of a pea turning into light and heat because it hit our atmosphere at high speed. Mercury has no atmosphere to do that. Every rock that comes in from space hits the surface at full speed. Mercury's surface is covered in craters because of this. Billions of years of unfiltered bombardment with nothing to stop it. You'd be standing on a planet that regularly gets hit by rocks traveling at tens of thousands of kilometers per hour, with zero warning and zero protection. Now let's talk about gravity. Mercury is small. Its gravity is about 38% of Earth's, so you'd weigh roughly a third of what you do now. In theory, that sounds almost fun. You could jump 2.5 times higher than on Earth. But in practice, lower gravity combined with no atmosphere means any loose dust or debris on the surface behaves completely differently. Mercury's surface is covered in a fine powdery regolith, ground-up rock from billions of years of meteor impacts. In low gravity with no air resistance, the dust goes everywhere and takes forever to settle. It gets into everything: joints, seals, visors. The Apollo astronauts on the moon, which has similar conditions, said lunar dust was one of their biggest problems. It was abrasive, it stuck to everything, and it was nearly impossible to clean off. Mercury would be the same, except the dust is also sitting on ground hot enough to melt metal. And here's the thing nobody thinks about: the sun. Mercury is about 77 million kilometers from the sun at its closest point. Earth is 150 million kilometers away. So from Mercury, the sun appears roughly 3 times larger in the sky than it does from Earth. 3 times larger. Just standing there and looking up, if you could even look up without being blinded, the sun would fill a massive chunk of the sky. The light intensity on Mercury's surface is about 6.5 times stronger than on Earth. Even with a reflective suit, the solar pressure, the literal pressure of light, is measurably stronger on Mercury. It's the kind of thing that sounds like a detail but hits differently when you're standing on the surface with it bearing down on you. So let's put a timeline together. You step onto Mercury's day side, unprotected. In the first second, the heat begins transferring into your body faster than it can escape. Your skin starts burning from the radiated ground temperature alone before the sun even gets involved. Within 30 seconds, you lose consciousness from heat stroke as your core body temperature skyrockets. Within a few minutes, your body reaches the temperature of the surrounding environment, and the biological processes that define being alive simply stop. The radiation was already working the whole time, but it doesn't matter anymore. Now, if you somehow had a suit that handled the temperature, the radiation would give you a lethal dose within hours. If you had a suit that handled both, A meteor you never saw coming could end it at any point. If you survived all of that, you'd need food, water, and oxygen, none of which exist on Mercury's surface in any usable form. The honest answer is you wouldn't last a minute. Not because you're weak, but because Mercury is a place where the rules that allow life to exist simply don't apply. Here's the thing that gets me, though. We sent a spacecraft there. Twice. Mariner 10 in 1974, Messenger in 2004, which actually orbited Mercury for 4 years and mapped the whole surface. And right now, a joint European and Japanese mission called Bepi Colombo is on its way there, scheduled to arrive in 2026. We looked at one of the most hostile places in the solar system and said, let's go take a closer look. And here's the comedic gut punch. You, right now, are sweating because your air conditioning is running a little warm. Your ancestors were out here on the African savanna with no sunscreen fighting lions with rocks. And you would not survive a single minute on the surface of Mercury, a planet we've already sent robots to. The robots are doing fine. The robots have been there for years. You, on the other hand, would be a puddle of lead-temperature human soup in under 60 seconds. We sent machines to one of the most extreme places in the solar system. The machines are thriving. You can't leave the house without chapstick. The universe is big. Most of it is trying to kill you. The fact that you're sitting here reading this on a planet with a perfectly calibrated atmosphere, a magnetic field, the right distance from the sun, and liquid water is not normal. It is a spectacular accident that has lasted 4 billion years. Mercury is just the reminder of what the rest of the solar system actually looks like without it. Enjoy your thermostat.